Yeah, thank you very much for the kind invite. I'm speaking here not on behalf of the IPCC. If I were to do that, then I could only present IPCC slides. Of course, I brought some with me, but also some of other global CDR assessments I've been involved in, most notably the state of carbon dioxide removal effort, which is a global effort now happening every year, but also the UNEP emissions gap report analysis from last year. So let's briefly start with the definition of carbon dioxide removal, and we're not going to read through it, or I'm not going to read through it. The terms here highlighted in red are the most important ones: anthropogenic activities removing carbon dioxide from the atmosphere and durably storing it in geological, terrestrial, or ocean reservoirs or in products. This is from the IPCC glossary. It was invented for the special report on 1.5. Anthropogenic activities is important, so not natural, for example, CO2 fertilization of forests from the atmosphere, not from smokestacks, and durably storing it. And durably storing is, of course, a little bit ambiguous, but it was better than what we had at that point in time. So from the State of CDR report, I want to show you a three-tiered figure to make clear how these principles can be applied. So from the atmosphere is principle 1, store it durably, principle 2, additional to natural processes. If we do what you do here, what Climeworks does together with Carbfix, capturing CO2 from the atmosphere, storing it, then it's CDR, because both principles, the most important principles, the third doesn't apply here, are being honored. If you use this CO2, although captured from the atmosphere, to, for example, produce synthetic fuels, then of course this CO2 lands in the atmosphere again, and if your whole process chain is CO2 neutral, then you get a CO2 neutral process, which is good for the aviation industry, but it's not carbon dioxide removal. And if you do this, let's say in a coal power plant or in a gas power plant, you start with fossil CO2 that is extracted via gas and coal or oil. Then, of course, principle 1 is not being honored. It's not from the atmosphere. You store it then durably, and you get close to a net zero process. Of course, the capture rate is not 100%. Of course, there will also be emissions evolved along the process chain. And then this very specific example of forestry. So if you just, and this is really goes into accounting details, but you will learn in a minute why this is important, or in 2 minutes, or in 3. So if it's just, you cannot just look at growth of forests and say, oh yeah, we're removing. So scientists are investing a lot of work in trying to figure out what are CO2 fertilization effects due to higher concentrations in the atmosphere, because then it would not count as anthropogenic activity, and there are accounting rules and reporting rules for national greenhouse gas inventories on that. But if it's about, if it comes from afforestation and reforestation efforts, then this kind of biological storage counts, of course, only as long as the carbon is actually stored in forests or the associated soils. Of course, it's a more vulnerable form of carbon dioxide removal, but it makes up most of it. So what changed in 2022 when this Working Group 3 report was published was that I think the CDR debate changed considerably. Of course, with the 1.5 target from Paris, and then you also have Article 4.1 saying net zero greenhouse gases by the end of the century. Net zero, what does the net mean? Yes, CDR was kind of there. At the same time, you had very high numbers, and we heard some of them today already, about what scenarios assessed by the IPCC assume in terms of CDR. But these numbers can be quite questionable if you look at the assumptions. It can be quite high. If I had time, I will go into the reasons. So those who didn't want to talk about CDR, and the summary for policymakers, you do that really in a room bigger than that with government delegations that cannot change the underlying report, but you negotiate in the language of the summary for policymakers. You saw in earlier drafts, okay, many governments, and you can really track that down. These drafts are public, and also the reactions by governments on these drafts are public. Many governments did not want to talk about, okay, there really is a need for CDR. So in a way, the author team decided, okay, then now let's make it very, very simple. Let's not talk about the numbers in the CDR section, but start with the basics. And the basics are the deployment of CDR is unavoidable if net zero CO2 or GHG emissions are to be achieved, or in even simpler language, because of course you get to diplomatic language. It says, if you already set a net zero target, you already said yes to CDR, because otherwise it would be just a zero emissions target. That took some governments by surprise, but of course that's just the way it is. And then the message is, yeah, you can of course come up with global numbers for CDR that you need under certain assumptions, but the major decisions, as Chris Davies told us today already, will be made on a national level. Levels of residual emissions will be different. The CDR you use will be different. So you don't need to go into global models to establish, yeah, net zero means CDR. If you have a net zero target, you said yes. Now please find out how you're going to get there. And of course, this to counterbalance hard to abate residual emissions has become, because of the net zero target, that's the other side of the coin. Of the net, what will they be? Can we pin numbers on it? That will be hard to do. This is a figure now not from a global assessment, just from an SWP policy brief, where we try to break that down and have a very agnostic way of saying, okay, residual emissions are just what it says. These will be the emissions still there, and then at the point of net zero for whatever reasons. And we can be pretty sure, and it's safe to say, there will also be easy to abate residual emissions left. If you just look at it from an economic or technological standpoint, there will also be a lot of, let's say, politically induced residual emissions. And to deal with them, we have carbon management. This is basically a term that came into fashion during the last years, and we heard that already. And we're kind of opposing here the notion that CDR is not CCS. No, CDR can have a CCS component. What it really depends on is what kind of CO2 are we talking about, and where does this CO2 go? So if the CO2 is from fossil sources, then CCU will basically delay hard to abate emissions, because only few of the CCU applications will lead to durable binding of the CO2. CCS will reduce hard to abate emissions, but never to 100%, and CDR can counterbalance residual emissions. Now, this stays basically in the frame that most countries are looking at right now, residual emissions under net zero. But if you look at and this is a figure from the IPCC report, at global modeling until 2100, and this is not a real scenario, it's just because surprisingly integrated assessment model scenarios are not very easy to grasp. If you look at them, we just produced a stylized pathway showing the basic components that you also would find on a national level. And then you have non-CO2 greenhouse gas emissions will make up the bulk of residual emissions, usually. Then you have residual emissions by the end of the century of fossil CO2, including the CO2 not captured by CCS processes. Like, okay, in a power plant you can maybe get 90 or even 95%, and we will probably improve on that. There are papers saying we can get to 100, but then it becomes very, very costly. But in industrial installations, it's often less. And then we have removal. We also have land use residual emissions. Usually these figures would not show that. So the managed land component. And then we do removals already via forestry, and then other removals kick in. And you have two dashed lines, and I will get to them in the next slide. But basically you have three strategic components. You reduce your net emissions before net zero, you need CDR to reach net zero, CO2 or GHG, and to go net negative, and I think that's kind of clear to everybody. You cannot go net negative without CDR. But one interesting element that policymakers often overlook is that the net zero trajectories for CO2 and GHG are different. So you might see that as an academic element, but I can tell you why it's politically relevant, at least on a global scale. So why does it occur later than net zero CO2? Because you only have CO2 removal right now. So if you split up the gases, then you overcompensate with CO2 removal, and then you need carbon neutrality, CO2 neutrality earlier. So all the targets we have in Europe, net zero, are greenhouse gas emission targets. We will all be net zero CO2 much, much earlier, and the more residual non-CO2 we have, for example, if you have a big agricultural sector like Ireland, for example, there would need to be net zero CO2 20 years before getting to net zero GHG. On a global level, it's often 10 to 40 years of a difference. But here comes the other misunderstanding. So we often hear the IPCC says we need to be at net zero by 2050, and that's basically, I think, where the Europeans got their 2050 from. But in the IPCC modeling, in the global modeling, it's net zero CO2. It's not net zero GHG. That's much later. So you could say, okay, in Europe, we are better than the average, as we should. Net zero GHG, under the way we account for non-CO2, would even lead to a slight decline of temperature. So to stabilize, we need net zero CO2, and we also need non-CO2 mitigation. With net zero GHG, slight decline under the GWP 100 emission metrics we use. I think it's important to differentiate this and also be aware, because if you would ask let's say a government, when will you be net zero CO2, they wouldn't know. They're all fixated on 2050. They also don't seem to grasp that the bulk of their emissions, residual emissions, for example, in 2050 will be mainly non-CO2 if they have agriculture. And it's not only agriculture, it's also F-gases and things like that. And it also explains the 2050 again, and I think that has not been well explained by the IPCC. We often hear the global carbon budget, which is really only about CO2, will be depleted by 2030 for 1.5. How can we then say, oh, net zero by 2050 is enough to reach 1.5? Because, and I will show that in the next slide, we assume net negative thereafter. If you don't like net negative thereafter, or if you think it's not feasible, then you need to be net zero in 2030, net zero CO2 globally. So on the synthesis report, you see that brought out a little bit more clearly. These are on the left hand, it's for 1.5, on the right hand, it's for 2 degrees. Also, the differentiation between CO2 and non-CO2 is a little bit better. You might really be surprised to see that the GHG number for 1.5 is 2095. I cannot go into this because, and what you learn there, that these numbers are made, they are not found. It's based on some, I would say, questionable assumptions why it's 2095, and these are not IPCC numbers in the sense of the IPCC produced them. The IPCC is only assessing the literature. Many of these 1.5 scenarios go net zero GHG only after 2100. But it's clear we have to be there, and we have to look at what's happening in the second half of the century. 2050 CO2 only because there is this net negative phase. And if you don't believe in it, then you can either have to say, okay, 1.5 is over, or we have to drastically reduce emissions by 2030, but I'm not sure if you can make a convincing case for that. So and whenever you hear the numbers, the IPCC says you need to reduce greenhouse gas emissions by 43% by 2030 and 60% by 2035 to stay below 1.5, then it's to stay below 1.5 by 2100 after a so-called overshoot period. That's already baked in. So these numbers are basically 1.6 and then getting down there. And again, you can question how feasible it sounds to be at minus 60% or minus 43% by 2030 compared only to 2019. So this overshoot phase is already part of the story, and overshoot means you can only return it with becoming net negative, and that's basically the case for CDR. Just a quick look at this. There are many figures to show the many methods and pathways you can have. This is a terminology that originally comes from Working Group 1, so the physical climate science. You have many, let's say, basic methods. We call it methods because pathways has a different meaning in the IPCC, although I like the term for CDR. Several implementation options per method, but what's important here, we don't work with the usual dichotomy, nature-based versus technological. We just say, okay, it's land or ocean-based, where's it placed. What's important is the removal process, but even more important, the time scale of storage. Now to the State of CDR report. If you look, at some point we found out, okay, we never hear a number. We know there's forestry, but we never hear a number. How much are we actually doing? It's not easy to track down and to calculate, but we developed a method in the State of CDR report that's being refined. It's right now 2.2 gigatons per year, although this is a decadal average because most of it comes from afforestation. The other so-called novel methods only make up a tinier slice. This was of course, going to change drastically. I mean, that the tiny slice will stay, but it's going to change in the near future, the numbers for novel CDR. The largest chunk right now coming from biochar, actually, but I think that and biochar is going to grow, and direct air capture with storage, and I think also enhanced rock weathering as well. But there are many methodological issues to find out what are we actually doing. So it's also about bringing together databases. And this is an overview slide. If you start from the right here, it's all forestry, what we now actually do, and also what we have in NDCs, national proposals of CDR. Demonstration and upscaling, if you look at investments in high-value patterns, it's a little bit more differentiated. And research and innovation, the scenarios are pretty heavy on BECS right now. They still are. They take on more methods. It's basically a proxy for non-afforestation CDR. And grant funding is also more differentiated. So I think policy needs to move from the right to the left in planning, because if you look at planning documents, for example, the European Commission, it's also still a big focus on afforestation and on BECS and DACs. Here basically you see a split up. You see the overall net emissions for CO2, and then you see on the left that in the scenarios assessed by the IPCC, that afforestation, reforestation removals are still expected to grow, but they will then level off. Also, it's a land issue, but it's also under a warming climate a durability issue, because you will get more disturbances. And basically, the non-LULUCF, the non-forestry CDR, will have to take off. And you see that after 2050, mitigation is basically carbon dioxide removal. Of course, there will be residual emissions until the end. I skipped that slide. It just shows what we talked about earlier. The major effort, of course, has to come from emission reductions until net zero. It's not about CDR mainly. Then in the state of carbon dioxide removal, we went with different market scenarios to calculate maybe the gaps we are in. We did that because if you hear a number like 10 gigatons from the IPCC by 2050, it's the whole range of the database, and the database is not of 600 scenarios or so, is then not a statistically controlled sample, so you have some distortions, and all these scenarios are very assumption-based, so it's interesting to say, okay, let's look at high-level CCS scenarios, look at low-level CCS scenarios because they are constructed that way. But whatever you do, if you compare it to NDCs, where we would need to be in 2030, where we would need to be in 2050, and compare it to long-term strategies, you see these differences. And just an additional thought, all these scenarios start in 2020 assume a falling off the cliff immediately emissions-wise, which in reality has not happened. So with every year that we don't reduce emissions drastically on a global level, the CDR demand will just rise. Now to policy. In the emissions gap report last year, it's a gap report that comes out every year, but in the second half they have specific chapters. For the second time, they had a CDR chapter. I was also, that I was leading. I was also involved in one 6 years ago. 6 years ago, everybody was only talking about methods, explain what can be done. Right now, last year it was much more policy focused and defining priority areas for CDR policy actions. Many of we have heard about today already: political priorities, robust MRV, synergies and co-benefits, innovation and learning. So that's no news to you at this point. And if you look at the European Union, you can see, although I would say on a much slower pace compared to the US, that things are happening already. As the US, as Canada, we have net removals from land use change and forestry. And by 2030, via legislation, all member states need to be net negative there. There are huge doubts if this can ever be achieved because we are not on track. It's going into a different direction, which would then mean the European Union would need to accelerate removals beyond LULUCF. We have EU Innovation Fund projects like BECS Stockholm, which is a dedicated CDR project, but we heard about the Coda terminal already because these process chains are connected, especially in transport and storage. And we have an EU expert group on carbon removal, that's how it's called. It's mainly working on methodologies in the context of what we will see in the near future, the carbon removal certification framework, where the political decision has already been reached, but it's not in the official journal of the European Union yet, because some formal decisions still need to be made. But this is just a pre-game. I think there's a huge overestimation of how important the so-called CRCF will be. What's much more important is when the EU decides about its 2040 target, which is going to happen next year or the year thereafter, and also on its NDC for 2035, which has to happen next year. The removal component will have to be defined, and I think then we will get to numbers and have an idea. Will it be the famous 280 mentioned today, or I think the 280 includes conventional CO2 storage as well. And what we will start seeing there, and that's interesting politics, differentiation among member states, because member states don't all have to be at net zero in 2050, and some count on not being at net zero in 2050, and we will have a flexible system. But politically, that's where we have huge differentiation already in the European Union, but having to go maybe even below net zero so others can stay above, I think this is a different kind of discourse. And those countries big on agriculture like Ireland, I cannot see how they get to net zero GHG by 2050, which means they would have to assume that other countries go net negative for them. And you can have flexible mechanisms, you can negotiate targets around that, but I think the politics of this will be very interesting. Also, if you then look at which sectors may need to deliver net negative. No sector beyond forestry in Europe says we are going to go net negative to maybe counterbalance agricultural residual emissions. And then clarification of carbon dioxide removal in EU emissions trading is something that the EU Commission is tasked already legally to come up with a report to present options, and it can be expected that in the 2030s we will have it somehow. There are many different models in the ETS directive, which may be negotiated by 28, I would expect. And in developments in member states, we have them, and some of them have mentioned. Germany has 2 strategies ongoing and also already decided to have non-LULUCF carbon dioxide removal sub-targets in the climate law, legally binding. Denmark has set, although only in a coalition agreement, a net negative greenhouse gas emissions target, minus 110% by 2050. They're the only country to already have a quantified net negative target. The European Union has it in the climate law, net negative after 2050, but not quantified. And Sweden now got finally the notification, which is a process by the European Commission to allow them to spend money on subsidies for a reverse auctioning scheme for BECCS. And I think this will be interesting to see how this plays out. And one of the major drivers in the European Union will be that when we increased our ambition for 2030, we changed what we call the linear reduction factor, LRF, for emissions allowances in the emissions trading 1. It was always assumed, okay, we will run out of allowances, so in what we can auction or hand out to governments by the end of the 2050s. Now it's clear if you don't make changes, it will by the end of the 2030s, which basically means that we need CCS in cement and other sectors, or green hydrogen for steel. But if you don't have a 100% capture rate, even if you do all this and the rest is renewable, there will be residual emissions left under the emissions trading system, so you need to integrate CDR somehow. And this works wonders in governments because they created a problem themselves, policymakers. It's not scientists saying, yeah, here you have Paris, and it would only be logical if you invest in CDR. No, and then it's based on more ambition and not on less ambition. So now governments and the European Commission are starting to think, okay, how do we integrate that CDR element into emissions trading, because otherwise the system would crash. Since I ran out of time already, I only mention it. The future will bring then another discussion that will be uncomfortable for the European Union. If net zero 2050 under global differentiation, does that mean that other countries, developing countries, can stay above net zero for a much longer time? Probably it should. So where does the European Union go then in the future? Do we have net negative targets? And if we have net negative targets, what will it be and what will be the role of CDR? This is the last slide. So the European climate law already says net zero GHG by 2050, net negative thereafter. And I think in the next years, the EU will have to decide and will be forced to decide, because India and China, South Africa are already asking about it, what will be the next target? Let's say for 2060. Is it then minus 110? Is it minus 100? The story will not end at net zero for the European Union. And what will be the CDR trajectory under that? Because you can say residual emissions will continue to go down. Maybe it's enough to keep the CDR levels we have in 2050, or do we need to expand on the CDR side? And that's what Germany is now doing in its strategy, to play around with indicative 2060 target levels and what would they mean for CDR. And I think this is the next strategic debate that's going to happen in the European Union, and it's going to heavily influence how we look at carbon dioxide removal, and especially that what comes after net zero question is one that will come to other OECD countries soon as well via global climate negotiations. Thank you very much.